Ladies and gentlemen, I want us to look at curve sketching in the topic of differentiation, and we can say that a rough sketch of a function can be drawn by finding the following. There are three basic things that you need to know when you want to sketch a curve. Number one is stationary points and determine their nature. Number one is you need to find stationary points. Now, after finding the stationary point, you need to determine their nature. And I can say that a stationary point can be a maximum, a minimum, or a point of inflection. Secondly, you need to determine that is the x-intercept. You need to determine that is the x-intercept. And the x-intercept is when y is 0. Then lastly, you need to determine that is the y-intercept. And the y-intercept is when x equals to 0. Those are the three basic things that you need to know when you want to sketch, that is, a curve of a function. For example, sketch the curve of y equals to, that is 2x squared minus 7x plus 3. That is, sketch the curve of y equals to 2x squared minus 7x plus 3. The first thing that you need to do here is to find the stationary points. The first thing is to find the stationary points, as we have said. So stationary points can be found by differentiating the function of y with respect to x, then equating, that is dy over dx, that is the derived function or the gradient function, with 0. That is the way you can do to obtain the stationary point. So let us differentiate this function of y with respect to x. That is dy over dx will be, this is a polynomial, and in a polynomial you differentiate each term in turn. So this is the first term. So for me to differentiate each term in turn is I will multiply this term with its index. I will multiply this term with its index and reduce the power by 1. So the power of the first term is 2. So I multiply, that is with the term that is 2x raised to 2. Then I less the power by 1 or reduce it by 1. Then this is the second term. We have this minus that is here. So this is the second term. The power of x here is 1. And since the power of x is 1, I will multiply this term by its power, which is 1, and reduce the power by 1. So I will have 1 into 7x raised to 1 minus 1. Then if I differentiate, that is positive 3, I will get 0 because positive 3 is a constant. Now we shall have, that is 2 into 2x raised to 2 minus 1 is 1. Therefore, this is x raised to 1, which is just x. Then minus 1 into 7x raised to 1 minus 1 is 0. Now, in this case, we shall have, that is 2 times 2x, which is 4x. Then minus, this is x raised to 0, which is 1, times 7 is 7, times negative 7 is negative 7, just that way. And this is, that is the gradient function. This is the gradient function that we have. Now, we can say that at stationary points, dy over dx is 0. Let us have this one first, that is the gradient function, 4x minus 7. Now, since this is our dy over dx, we have said that at stationary points, we can say dy over dx, that is at stationary points, dy over dx equals to 0. Now, since our dy over dx is 4x minus 7, instead of dy over dx, we shall have 0 equals to 4x minus 7. That is, we can say that 4x minus 7 equals to 0. Now, from there, we can say that 4x equals to 7, because if we take this negative 7 to the other side, it will be positive. Then we shall divide by 4 and also divide here by 4. So that by 4, 1, by 4, 1. And therefore, we can say that our value of x is 7 over 4. Or if we write it as a mixed fraction, we shall have our value of x as 1 and 3/4. That is 1 and 3 over 4. That is 1 and 3 over. Now, since we have our value of x, we need to determine, that is, the value of y when x is 1 and 3 over 4. Because for us to obtain, that is, the stationary point, we need to obtain, that is, the value of y, so that we write it as a coordinate. Because a stationary point will always be in the form of x comma y. Now, when x is 7 over 4, our y will be, that is, our y will be, we substitute it in our original, that is, in our original equation of the curve, and it will be 2, instead of x, we shall have 7 over 4, then squared, then minus 7, instead of x, we shall have 7 over 4, then plus, that is 3, plus, that is 3. So we have 2 into 7 over 4, and then squared, minus 7 into 7 over 4, plus 3. Now from there, we can say that y equals to 2 into 7 over 4 squared is just 7 over 4 times 7 over 4, which is 49 over, that is 16. 49 over 16. Then we close the bracket that way. Minus 7 times 7 over 4 is just 7 times 7, which is 49. Then over 4, which is in the denominator, which is in the denominator. Now, then plus 3. So in this case, by 2, 1, by 2, 8. Therefore, we shall have our y equals to, that is 49 over 8. 49 over 8 minus 49 over 4, then plus 3. Now, this is 49 over 8 minus 49 over 4. These are the only fractions that we have. Therefore, we can combine this one. We can combine these fractions to be a fraction of a single number, so that that is y equals to, the LCM of 8 and 4 is just 8. 8 divided by 8 is 1, times 49 is 49, minus, this minus, 8 divided by 4 is 2. Then times 49 is just 98. That is 98. Then we shall have here plus 3. Now, our value of y will be, that is 49 minus 98 is just negative 49 over 8, then plus 3. Now, this one is just the same as, that is 3 minus 49 over 8. That is 3 minus 49 over 8. That is 3 minus 49 over 8. And if we press our calculator, 3 minus 49 over 8 what do we obtain? What do we obtain? That is, in our calculator, we shall have, that is 3 minus 49 over, that is 8. That is 3 minus 49 over 8. What do we obtain? We obtain negative 3 and 1 over 8. And that is the value of y. That is the value of y will be, negative 3 and 1 over 8. Negative 3 and 1 over 8. Since we have x as 1 and 3 over 4 and y as negative 3 and 1 over 8, we can say this is our stationary point, which is x is 1 and 3 over 4. Then our y is negative 3 and 1 over 8. Now, this is our stationary point. Now, we need to determine the nature of this stationary point. We need to determine the nature of this stationary point, whether it is a maximum, a minimum, or a point of inflection. Now, this is our stationary point, so we need to determine its nature, whether it is a maximum, a minimum, or a point of inflection. Therefore, the value of x here is 1 and 3/4. That is 1 and 3 over 4. Now, since we have that, we shall write it at the center. This is, we have this column, and this column. Therefore, we write in the, that is in the column that is in the middle. Then, to the left of 1 and 3 over 4, 1 and 3/4 is just the same as 1.75. Now, to the left of it, a whole number that is to the left, it can be 1. Then a whole number that can be to the right, it can be 2. Now, we need to determine the value of dy over dx when x is 1, and also the value of dy over dx when x is 2, because we know this one, the value of x, the value of dy over dx in this is 0. Now, when x is 1, dy over dx, our dy over dx is 4x minus 7. Therefore, if we substitute here with 1, it will be 4 times 1, which is 4, minus 7 is 4 minus 7 is negative 3. Then our dy over dx when x is 2, that is, we shall have, that is 4 times 2, 4x, that is 4 times 2, which is 8, minus 7 is 1. Now, the sign of the gradient here, the sign, this is negative, so we shall have negative, this is 0, and this is positive. Now, since we have that, the diagrammatic representation will now be, that is negative, 0, then positive. Now, this one is a minimum point. This one is a minimum point. We can therefore conclude and say that the point that is 1 and 3/4, comma, negative 3 and 1 over 8 is a minimum point. It is a minimum point. It is a minimum point. Now, from there, after obtaining the stationary points, let us proceed, that is, to find the x-intercept and the y-intercept. Now, the x-intercept, that is, at x-intercept, y is 0. Now, instead of y here, we shall have 0 to obtain the x-intercept. Instead of y, we shall have 0. Therefore, we can say 0 equals to 2x squared minus 7x plus 3. We can rewrite this one as, that is 2x squared minus 7x plus 3 equals to 0. So that we can have 0 on the other side. Now, This is a quadratic equation. This is a quadratic equation. Now we need to obtain the value of x in this quadratic equation. There are several formulas that you can use to obtain the value of x in quadratic equations. There is the factorization method, then there is the completing square method, then we also have that is the quadratic formula, and finally the graphical method. There are 4 methods of solving that is quadratic equations. That is, the first one is factorization method, the second one is completing the square method, the third one is the quadratic formula, and lastly the graphical method. Now let us use factorization method in this. In factorization, we can say the sum is the coefficient, that is b. Our b here is the coefficient of x, which is -7. Then the product is ac. That is, our a is 2, our c is 3. Therefore, the product of 2 and 3, that is 2 times 3, which is 6, and that is our product. So we need to find two numbers. When we add them, we get -7, and when we multiply them, we get 6. When we multiply them, we get 6. Two numbers that when we add them, we get -7, and when we multiply them, we get that is 6. The two numbers can be, that is -6 and -1. If you add -6 and -1, you will obtain -7, and if you multiply them, you will obtain 6. Now, we shall rewrite this quadratic equation as, that is 2x squared. So instead of -7x, we shall have minus this 6x, then minus x or -1x, so that we don't change anything. Then we shall have plus 3 equals to 0. That is plus 3 equals to 0. Now from there, it is now simple to find the value of x, because we just group this and also group this one and this one, and also group this. Therefore, we shall have, that is, what is common between these two is 2x into, we shall have x minus 3. Then what is common between x plus 3? This is -x plus 3 is -1. That is into x minus 3. Then equals to 0. Now having this, we shall have this one and this one are the same. We can say x minus 3, that is grouping. Then we shall have 2x minus 1. That is 2x minus 1 equals to 0. Now at this point, we can say that x minus 3 is either 0, that is x minus 3 is either 0, or 2x minus 1, the whole of this, equals to 0. And in this case, we shall have, that is our value of x as 3, or in this case, we shall have 2x equals to 1, then over 2 over 2. And therefore, in this case, we shall have our x as a half. Now, that means our intercepts, that is our x-intercept, it will be, that is the point, our x is 3, then y is 0. And also, we can say this is the first point. Then the second point occurs when, that is x is a half, then we shall have our y as 0. Now, these are the x-intercepts. These are the x-intercept. These are the x-intercepts. That is, we have 2. That is 3, 0, and also a half, 0. Now, let us also have a look at the y-intercept. The y-intercept, that one at y-intercept, our x is 0. That is, x is 0. At y-intercept, x is 0. Now, at y-intercept, x is 0. If we substitute the value of x here with 0, what is our y? We shall have, that is, 2 into 0 squared, then minus 7 into 0 plus 3. Now, this one will be, our y will be, this one will go to 0 and this one 0. Therefore, we shall have 0 minus 0 plus 3, and that is 3. Now, that means the y-intercept will be, the value of x is 0. Therefore, we can say it will be 0, 3. This is the y-intercept. This is the y-intercept. Now, we shall now therefore have these 4 main points. But this one was a stationary point. This one is, that is the x-intercept, and this one. Then this one is, this one is the y-intercept. So this one and this one is the x-intercept, then this one is the y-intercept, and this one is a stationary point. Now, for us to sketch this curve, we need to consider these 4 points. We only consider these 4 points. Then we sketch it, and that will be now the sketch of our curve. Now, this is our Cartesian plane that we have the x-axis and the y-axis. Now, having that, our stationary point was 1.7. That is not 1.7, but that is 1.75, because it was 1 and 3/4. That is our stationary point, 1.75, which is the same as 1 and 3/4. And also -3 and 1/8, which is the same as, that is -3.125. Now, since this is our Cartesian plane, then we need to plot this first point, which was a stationary point, that is 1.75. 1.75 on our x. This is 1.75. Let us approximate it as here. Then, comma, on our y-axis, we shall go down, that is negative, towards the negative. That is up to, this is 3, then -3.125, let's say it is here. Now, this is our stationary point. This is the location of our stationary point. That is where we can plot our stationary point. We have put it, we have put a dot there. Now, let us have a look at the second point, that is the x-intercepts. Our x-intercepts was, the first one was 3, 0. Now, that is 3 on our x-axis and 0 on our y-axis. This is the x-axis, positive 3 is here, then y is 0. Therefore, this is the first, that is the point. Then we also have the second, that is the second point of, this was point 2, point 3. Our x-intercept again was 1, 0. That is not 1, but a half. So if this is 1, a half, we can say it is here. So a half is here. So this is a half on the x-axis and 0 on the y-axis. A half is like 0.5. So it is here. It is in between 0 and 1. Then our fourth point was the y-intercept. Our fourth point was the y-intercept, which was 0.3. It was 0.3. Now 0.3, that is 0 on the x-axis and 3 on the y-axis. Therefore, it will be 0, comma 3. Our 3 will be here. Therefore, if we sketch, it will be, we start here. So we shall start here. Let's say we have this. That is what we shall have. This is what we shall have. That is, this is the curve that we shall have. So in sketching the curve, you use a freehand. That is, you can sketch it here. It should be a curve. It should be a curve that way. Now, that is how we can sketch a curve in the topic of differentiation. That is how you can sketch a curve.